All right, we're going to go over your Monday warm-up. This is going to be week 1.7. Number 1, a group of science students is investigating states of matter. They conduct this investigation. 2 identical balloons, so 2 of the exact same balloons, are tied to opposite sides of a balance scale and 1 balloon is inflated. What question could this answer? Remember, when you're looking at scientific experimental questions, everything has to match. So my picture of my experiment needs to be able to match and hold up to the question that I'm asking. So I'm going to look for that as I look through these answer choices. So how much air can a balloon hold? So if I look back at my experiment, they haven't included any measure of how much air they're putting into the balloons. They haven't, they've only put air into one balloon, whereas if they were measuring how much air can a balloon hold, they would probably want to introduce several balloons to test out this question. So that's not going to be an answer that fits very well. Can larger balloons hold more air? So the problem with this one is they didn't use larger balloons. Remember, the balloons were identical. They were exactly the same balloon. So to be able to answer this question, we would have needed to test a smaller balloon and a larger balloon. But they didn't do that. They chose 2 of the exact same size balloons. Does air have mass? Well, we are working with air. They filled the balloons with air. And we did measure mass because if you look at this, it is essentially a balance scale. The way that they've constructed this wood piece right here is essentially acting as a balance scale, which does measure mass. So we'll come back to that one. Are water balloons heavier than air balloons? Well, we didn't use any water balloons at all, so we cannot answer that question. So this is going to be the best answer choice here. Because they did measure mass, and their variable actually was air because they did not put any air in this balloon, and they did put air in this balloon. So air is their variable, and mass is what they measured. And remember, you take your variable and the thing that you measured, and that usually addresses your question as well as your conclusion. And what they found from the experiment, you can see from the picture, is that yes, air does have mass because once they filled the balloon, compared to the empty balloon, that part of the scale sunk down, which means that this side of the scale is heavier or has more mass. So air does have mass. So C would be correct. What physical property can be used to classify the following objects? So remember, physical properties are things like magnetism, solubility, conductivity, physical state, etc. So we've got 4 items here, and basically we want to be able to classify them into 2 groups. So another way to phrase this question would be, how are these items different? Or how can you classify these items into 2 different groups? So we're looking for how these items are different from each other. And that'll make more sense as we go through the answer choices. So for example, let's take magnetism. So we have a wooden craft stick, which is non-magnetic. We have aluminum foil, which is non-magnetic. Copper penny is not, and cotton mitten is not. Okay, all of these items are not magnetic. So if we were to sort them by their magnetism, we would only end up with one group of items. They would all stay in the same group together because they all have the property of not being magnetic. Okay, but we want to classify these groups into 2. We want to classify these objects into 2 groups. So magnetism won't work. So I'm going to erase these real quick, get them out of the way. So magnetism is out. Okay, solubility. So let's see if they have different solubilities. Wooden craft stick would be insoluble. Aluminum foil, insoluble. Copper penny and cotton mitten, they would all be insoluble. So they actually have that property in common. So we wouldn't be able to sort these items based on that property because we wouldn't end up with 2 groups. They would all be in the same group. Physical state. So remember, physical state is solid, liquid, or gas. So wooden craft stick is a solid. Aluminum foil, solid. Penny and mittens, all are solids, so that won't work either. Conductivity. So we have a wooden craft stick would be an insulator. Aluminum foil would be a conductor. Copper penny, conductor, and cotton mitten, insulator. So we've got 2 insulators and 2 conductors. So if we were to sort them based on their conductivity, we would end up with a group of insulators and a group of conductors, and that would give us our 2 classification groups. So conductivity would be the best choice. Jared's making a list of processes on Earth that are affected by the sun's energy. What process does not belong? So this is a third grade review. Think back to when you learned about the water cycle and the things that the sun does on Earth. This is something we'll learn about, and you've learned about in third grade, and we're going to build on in fifth grade. So he is saying that everything on this list is powered by the sun, and we're looking for the thing that does not belong. So I'm just going to go through and check off or put an X next to them if they don't belong. So photosynthesis is when plants use the sun's energy to make food. So that would be a process that is affected by the sun. So that would work. The water cycle. So remember, the water cycle depends on the fact that the sun's heat warms up the oceans and lakes and causes them to evaporate and puts water vapor into the air. So the water cycle is very much affected by the sun's energy. Volcanic eruptions. So volcanoes erupting, does it have anything to do with sun's energy? No. And then wind. So remember from last week, wind, I think there was a question on your warm-up last week, wind is created by the sun. So wind is created because of the rotation of the earth, and the uneven heating of the earth's surface creates warm pockets of air and cool pockets of air, which move as the earth spins. So the wind is powered by the sun. So the only thing here that doesn't have anything at all to do with the sun would be volcanic eruptions. Okay, we've got some check boxes for the last two. So place a check next to each substance that is soluble in water. So remember, if it's soluble, that means it dissolves. So it needs to, if I mix it into water, it would need to break up and mix evenly into the water. And liquids can be soluble just as much as little particles of solids. So honey would be soluble. Remember, sand is not. Iron filings are not. So if you mix sand or iron filings into water, you can stir and they'll spin around as the water is moving, but then they'll settle to the bottom as soon as you stop stirring. They'll never dissolve. Okay, syrup, if you stir pancake syrup or maple syrup or any kind of syrup, corn syrup, if you stir any of those things into water, they're going to dissolve. So remember, syrup and honey are both really dense. So if you pour them into the water, but do not stir, then they will settle at the bottom because they're more dense than water. But if you stir them, which is what you have to do when you're testing for solubility, if you stir them up, the honey and the syrup will both dissolve. And that's because their base is made of sugars. And sugars are soluble. Okay, salt is also soluble. Lemon juice, so think to lemonade. When you have lemonade, the entire cup is yellow, right? It's not just yellow on the top or the bottom. So it's yellow all throughout because when they made that lemonade, they mixed in lemon juice and it was able to mix evenly with the water. Remember, oil will sit on top, and if you stir it, it'll break up into bubbles, but those bubbles will want to float to the top as well, so that it will never dissolve into the water. And place a check next to each adaptation that would be beneficial, so something that would help an animal living in water. So large beak for crushing seeds seems more like a jungle adaptation or a forest. Long tail for grasping sounds more like something that needs to be able to climb. Scales would work, like fish scales. Gills, we know fish have gills. So extra large ears is actually a desert adaptation. So this is an adaptation for animals living in very hot climates because their large ears allows heat to escape their body. So it helps them maintain their body temperature. So this would be a desert adaptation, not a water adaptation. Webbed feet, of course, would help them move through the water. And of course, strong tail and fins would also work. And that's it.